Algebra 2, we're back for our final review video using the practice guide questions from the state. Let's not bother with waiting around here. Let's just go ahead and get started. And this is number 3. Okay, so we've got an inequality equation to solve. Excuse me, inequality equation. That makes no sense. Absolute value equation. Trying that again. All right. Click on the number line to select each value that is a solution of the equation. Select all correct solutions. Remember, you should have more than one here, probably 2 solutions. Most likely 2 solutions, but you got to check them, make sure they're not extraneous. All right, so we're going to solve this equation without the absolute value bars to begin with. And I'm going to multiply everything by 8, because fractions, we get this. We add 2 to each side, and x equals 6. So we're definitely going to have a point plotted at x equals 6. So there we go. And then we're going to do the same thing, except because it's absolute value, we set it equal to the opposite of the right-hand side. A couple things to remember as I write this out. If you needed to, you might have to isolate that absolute value expression. So that's one thing to think about. Comes out to -2, which would be right there. Okay, double checking by plugging them in. In this case, there really can't be any extraneous solutions for this particular problem because the right-hand side is positive. So as long as whatever's in the absolute value comes out to 1/2, then we're good. And 1/8 times 6 is going to give you 3/4 minus 1/4 is 1/2. And 8 times -1/2 gives you -1/4, so -1/4 minus 1/4, -1/2, absolute value, 1/2. So we do indeed have the 2 solutions that are correct. Next question. Click on the box. Click on a box to choose each factor you want to select. Choose all correct factors. So we got 6 to choose from. They're giving us the zeros. So it's a cubic function. We know there are 3 factors. So it's x minus 0. So x plus 1 is one of our factors. There it is right there. And then this one, x minus -2/3 is x plus 2/3. Now that's not listed, but if you then multiply by 3, you get 3x plus 2. That's listed. And that's the one that would yield you a -2/3 if you use the zero product property. And the last one's x minus 5. Easy peasy. That's not a difficult question as long as you know the concept. The zeros give you the factors. Okay, also the factors can give you the zeros. Just depends on your circumstance. Next one. Type your answer in the box. Your answer must be an integer. Family Reunion Planning Committee with 8 members plans to select 3 officers: president, treasurer, historian. We automatically know order matters here because it would matter to you whether you were the president, the treasurer, or the historian. If each office is to be held by one person and no person can hold more than one office, in how many ways can those offices be filled? Well, this is a permutation of 8 things taken 3 at a time. I know that most of you will probably use your calculator to do this, but I'll go ahead and write it out. There's the formula, p factorial over p minus, no, not p, n factorial over n minus r factorial. Sorry about that. Just found the wrong variable in my brain there altogether. So that's the formula that I just used. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3, but that's 5 factorial. 5 times 4 times 3 times 2 times 1. And this is 5 factorial in the denominator, and those cancel. So 8 times 7 times 6. And just double checking, I think I know what that is. When you do problems like this a lot, that's something that comes up. 8 times 7 times 6, 336. And that is the correct answer. Moving right along. Type your answer in the box again. Another TEI. Round to the nearest integer for this one. The volume of a container varies jointly with the square of its radius, r, and its height, h. So let's write that. Now, it says a container. I read it at first as a cylinder, and I was like, well, duh, the constant would be pi. But I can't say that the constant's pi here because it doesn't say it's a cylinder. So it varies jointly with the square of the radius and the height. So there's the formula. We're going to plug in the values they give us. 377 cubic centimeters for the volume, 6 centimeters for the radius, 10 centimeters for the height. So you're going to go ahead and solve that. So 377 equals 6 squared is 36 times 10, 360 K. And our constant is 377 over 360. I'm going to keep that. So now I have the formula 377 over 360. It's like 1.4 something. But I'm not going to round it off. I'm going to leave it a fraction. Now all I have to do is plug in the numbers they gave me. 377 over 360 times 4 squared, 4 for the radius squared, times a height of 4. We're going to use our trusty TI calculator. 377 over 360 times, it's really 4 to the third power there, isn't it? 4 to the third power. I get 67.022222, so 67.02 with the 2 repeating. We're going to knock that off. 67 is the answer that goes in the box. All right, almost done. Place points on the graph, another TEI. Place points on the graph on the x-intercepts of the graph. You must place points on each intercept. Well, that's not hard at all. Let's use red. 1 here, 1 here, and 1 here. Just be really careful with the wording. They just want x-intercepts. If they wanted y-intercept, you'd have to plot that as well. Keep in mind that we'll let you plot more points than are necessary. It will let you plot fewer points than are necessary. You've got to know what they mean by x-intercepts, and you've got to plot them correctly. Not hard, though. Next question. A solution to a quadratic equation is negative 16 minus 8i root 35. Which of these must also be a solution to this equation? Well, imaginary or complex solutions come in conjugate pairs. The only thing that would change in the conjugate is the sign that's in the middle of that expression. The sign of the 16 to begin with, that's not going to change over here. Still going to be negative. It's just this is going to be plus. It'll still be 8i, still be root 35. Which means that we have answer selection B. So it's just knowing the relationship, and again, that's a conjugate pair, and the difference is only whether it's a sum or a difference. Next. Home stretch now, guys. Okay, click and drag each, another TEI. Now remember, there's more TEIs on the practice, because this is the document that's also meant for teachers to learn how to teach how to do TEI questions. So it's not just for the kids to learn, it's also for the teachers. Okay, so this one, click and drag each selected expression to the correct box. So we've got a division expression to do. So first I immediately notice the negative leading coefficient. I'm going to take out a negative 1. I'm going to take out that negative 1, leaving me 2d squared minus d minus 15. And again, I see also on the bottom 9 minus d squared. That's a difference of squares. But I should notice that I can take out a negative from there also. I'm also going to change it to multiplication. Write 2d plus 11, 2d squared plus 11d plus 15 in the numerator, and put my 4d plus 1 in the denominator. Now I'm not going to go over factoring, but I will point out a few things. The ones cancel. When I factor this one up here, I know it's got to be 2d and d. I know it's got to be 3 and 5. One of them's negative, and that's going to be a minus 3, and that's going to be a plus 5. And this is a difference of squares, d plus 3, d minus 3. And then over here, 2d, and again, 2d and d. And it's got to be 3 and 5. I want to put the 3 over here, gives me 6d, and 5d gives me 11d in the middle. So clearly, the factoring may not be that fast for you, but I know you guys can do it. Now we start going at canceling. So a few things I already had to remember to make sure I switch the division to multiplication and flip over this right-hand fraction, the divisor, if you will. Let's cross out the common factors, this one and this one. Now, we already got rid of those 1s up there. How about diagonally, this one and this one? So what I have is 2d plus 5 times 2d plus 5, meaning this goes in the numerator, over 4d minus 1 in the denominator, and we're done with the problem. What is it? 5 more. Click on a box to choose each expression you want to select. You must select the 2 correct expressions. Oh, check it out. They tell us how many. Well, that doesn't always happen. All right, so this one is a radical. It's a 6th root. Identify each expression equivalent to this radical. Select the 2 answers that are correct. So this relies on us understanding that we can express this as a radical, like this, or as rational exponents, like you see in some of these examples here, okay? So first of all, the 6th root of 729. Keep in mind if you go to your math menu, you can do a 6th root. That comes out to a 3. So the 6th root of 729 is 3. So I know I'm going to have a 3 in my answer, and I'm definitely not dividing 729 by 6. That's not what a 6th root does. We know that, so we know we've got that part. Now there are 2 ways I need to think about writing this. So I'm going to have a 3. I can write it with rational exponents, where the exponent is the numerator, the index from the root is the denominator, and the same thing for r. So 11, 6. So we found one answer already, right here. Not this one with the fractions upside down, and definitely not this one over here with the 11 and the 5, because it doesn't go evenly. 6 doesn't go into 17 11 times, so there's no way that could be right. This one has to be the other one by process of elimination, but let's confirm it. All right, if I think about this radically, I have the 6th root of 729, and then I can make q to the 12th times q to the 5th, q to the 17th. I should have said I can make q to the 17th, q to the 12th times q to the 5th, and I can make r to the 11th, r to the 6th times r to the 5th. I can take the 6th root of these two because those exponents are divisible by 6. All right, I already have my 3 right here. The 6th root of q to the 12th is q squared. The 6th root of r to the 6th is r. And then left over inside the, oh, I want to make it a cube root. Inside the 6th root, I still have q to the 5th, r to the 5th. And that confirms it. That bottom right-hand corner is my second solution or answer. Since we don't really solve anything, just my answer to the question. Next. Oh, goody, a complex fraction. But thankfully, look, it's multiple choice again. Yay. Okay. So we're going to start by writing it as a division problem. And I'm not going to write negative 13 plus d. I'm going to write d minus 13 over 42d to the 3rd power divided by 13 minus d. Well, that's actually not going to help us, but we can rewrite that. Anybody already see a good way to rewrite that, hopefully? First, I'm going to rewrite it as multiplication. So 42d cubed on the bottom times 6d to the 9th on the top. And instead of 13 minus d, how about negative 1 times d minus 13? Much better. Cancel the d minus 13s. Cancel d to the 3rd with 3 of these, leaving 6. And then 6 goes into 42 7 times. So let's multiply across what's left. We have a d to the 6th on the top and a negative, don't forget about that negative 1, negative 7 on the bottom. So negative d to the 6th over 7, which is d. That's the closest one to what I just wrote. Because remember, a negative sign can go out front or on top when you have a fraction. Home stretch, 3 more questions, 35, 36, and 37, and we're done. Okay, the graph of the function is shown on the grid. This one's nice and quick. So we've got this function that starts at this point and goes to here, has an open circle, jumps down to this value at x of negative 1. It's a 1. And then we go down to this value, also an open circle, and it goes up to 2. So domain, remember we're talking about domain, from negative 5 to 2. Now, even though there's the jump here, there is still a value for this function at x equals negative 1. So that is actually okay. We are actually allowed to keep that. And this ends up being considered a continuous domain. It ends up being b. You don't worry about the jump that you see there with the openings there, with those open circles. Because what's happening is there are values of x that come right up to negative 1. So negative 1.00001 still in that domain, and it's approaching this value. But when it gets to negative 1, the value jumps down here. And then when it gets above negative 1, so like negative 0.9999, it jumps down to here and keeps going. So you've got your domain right here, no worrying about any sort of breaks in it or anything like that. Okay, and what's this one doing? This one is doing the range. So don't get caught with the domain and the range there. 2 more. Which of the following describes the end behavior of this function as x approaches 0? So I graphed it, and we basically get something that looks like this. And so as x is getting closer and closer to 0, this is going downward and approaching negative infinity. Now let's think about what's going on there. So as x is getting closer and closer to 0, x is a teeny, 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 tiny number. So if x is a teeny, 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 tiny number, we're finding the exponent that would be on a 10 to give us a teeny, teeny, tiny number. Well, that would be a really negative exponent. So as that exponent gets more and more and more and more and more negative, the value of this approaches negative infinity. It gets further and further negative. All right? But the visual method is what worked there. Next question. Last question even, and it's a properties one. Not hard at all. So what's the first thing that happened from here to here? They done jumbled it all up. That's our commutative property. C for change, O for order. Goes right there. All right, what did they do next? Well, they took and they put parentheses around the ones that need to be grouped together. Grouping, that's associative. And finally, what'd they do? Look carefully. They took the I out from the two terms in here and put it outside. That is the distributive property, albeit backwards, but it is still the distributive property. And those are your 3 parts of your answer. And that concludes our final SOL review video. Hope anyone else that's enjoying everything on my YouTube channel is also getting ready for the SOLs. I hope everybody does really, really well. Take your time, use your scratch paper, write it out, and let us know in the comments how you do. All right, see you in class.